Okay, we're going to be doing lead code 242, valid anagram. This is, if you've done lead code 383, which is ransom note, this is the same exact problem with a few minor twists. So you're given two strings, S and T, and you return true if T is an anagram of S and false otherwise. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once, right? So our input is, so as you can see, this has the same length as this, and all these letters can be arranged to form this, and this can be rearranged to form this. This has the same length as this, but at the same time, these letters cannot be rearranged to form this, right? So the lengths of these two may be different, but they're between 1 and 50,000, right? So the first thing we do is we check if they are not the same length. Because if they're not, then we already know it's false, because formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once, right? Supposed to use all these. So if length of S does not equal to length of T, you simply return false. Next, we convert one of them into a hash map so we can, so now we know they're both equal length. So we can iterate through the other and check in the hash map. So we'll convert, say, S, right? So we'll call it sh map is equal to counter of S, right? We iterate through the other string, in this case T, and check if a value in T is not present in sh map, or if it's present and its value is set to 0, i.e. we have used up all occurrences of that letter, then we return false. Otherwise, if we iterate through all of them with no issues, then we return false. We return true, sorry. So let's do this. So for character in T, which is this other string, we're going to iterate through this H map, which contains the S values and their number of occurrences, and we'll decrement them if we find them here. So if character not in sh map, in other words, it's not a key in the sh map, or sh map at character is equivalent to 0, i.e. it exists in the hash map, but they've all been used up, we simply return false. Else, it exists and is not yet used up, so we decrement it. So it will be sh map at car minus equals 1. So if we go through, we have reached here. So that means that all our characters exist in both strings equally. So we return true. Let's run this. Voila. Voila, it works. And the solution is O of n, right? And the space complexity here is O of 26, which is equivalent to O of 1, because there are only 26 letters in the alphabet. So it will never grow bigger than that, right? So this is our solution to valid anagram. All right, thank you and bye.